So I'm just making this video about finding the intersection of a line and a sphere. So the first thing to consider is the vector form of a line. And then a sphere may be given like this, but there are other forms as well that we'll look at in an example. So think of the line more like this. So every single point on the line has x coordinate a plus lambda p, b plus lambda q, and c plus lambda r. And basically you can just substitute that into this equation to find the value of lambda, and then plug the lambda in to find the points of contact. So it's actually not that difficult, but obviously, just like with any Extension 2 topic, you can get thrown curveballs and get some pretty tricky questions. So my first example is to find the intersection of this line and the sphere. So that sphere is centered at 0. A couple of ways you can think about this. One way to think about it is just that the points on this sphere are square root of 27 units away from the origin, because the center of this sphere is at the origin. So let's have a look firstly at the points on that line. So all the x coordinates are going to be 3 plus lambda times 1. The y coordinates are going to be the 2 minus lambda, and the z coordinates are going to be -1 plus lambda. So every single point on that line has those values, the parametric equation for that line. So one way to think about it is plugging the points into this equation. Another way to think about it is finding the distance of this from the origin. So here I've done it by plugging them into that line. So just plugged each of those into there as follows. Expand it out, simplify it down, find a value for lambda squared, which is 4, so lambda has to be plus or minus 2. It's really as simple as that. Find the points of contact. Now, it could have no points of contact, it could have 1 point of contact if it's tangent, or it could have 2 points of contact, a line passing through a sphere. By plugging lambda back in, we can find the first point of contact. Let's put lambda equals +2. So that's the point 501. And the second point of contact, we'll put lambda equals -2. So that's the point 141. Those are the 2 points of contact. In example 2, we're asked to find the radius of this sphere, given that this line is tangent to the sphere, and also find the point of contact. So this is just a different form of a sphere, and this here is the center of the sphere. You could think of the V as XYZ. The distance between XYZ and this point is equal to R. So that's just that other form of a sphere. So first of all, the center of the sphere is the point 2, 3, -4. The points on this line all have those coordinates, and the distance from the center of the sphere to the point of contact is the radius of the sphere. So I'm thinking of this one much more in terms of distance. So let's find the distance between those points. So subtracting and squaring the x's, the y's, and the z's would give the radius squared. And that's exactly the same as plugging it into the equation of the circle as well. So let's expand that all out and simplify. You can see I've brought the r squared over to this side. Now, in order for the sphere and the line to be tangent, they need to only have 1 point of contact. So what we know is the solution to this equation, that the discriminant is going to be 0. So 1 point of contact means that b squared minus 4ac equals 0. So let's plug in our a, b, and c to that equation and expand and simplify it out. R squared is 870 over 59. Now r has to be a positive number because it's the radius. So r is the square root of 870 over 59. So that's our radius, that's the first part, and 3.84 to 2 decimal places. So the next thing we had to do is also find the point of contact. So we need to plug that back in to find out what the mu is. Now the discriminant is going to be 0. I've just plugged in the r squared there and simplified it. I did write all this down, but we know that's 0 already. We've already found that that's 0, but we can double check it, of course. So mu is equal to negative 29 on 59, and we just need to plug that back into here. So plugging it back in, the point of contact is, there it is in, and work that out. That is our point of contact, just one single point of contact. I hope that video's helped understand this a little bit more.